Let me start with a very short story. A very, very long time ago, there were some beings that were alive, but then they weren't. They died and became fossil fuels, our main source of energy. The end. Regardless of what your point of view is on global warming, which, by the way, it's true, I think that most of us can agree that the characters in the story were by no means infinite, meaning that fossil fuels aren't either. This is the reason why there's a whole bunch of us engineers out there trying to come up with ideas to power up the world using renewable energy sources. In fact, the US Department of Energy wants to cover 1/5 of the energy needs of the country using wind power alone. And to do so, we build wind turbines that can capture wind energy. The principle is simple. The wind pushes the blades rotate, and we use the spinning energy and convert it into electricity. One big part here are the blades. Their current design and operation can actually capture 45% of the energy that is available in the wind. This might sound a little low, but in fact, the laws of physics tell us that we're only 15% away from the maximum attainable energy. For my PhD, I am working on redesigning the blades to capture more energy, and I'm doing so by using the power of salmon. You know how salmon have to swim against very powerful currents, right? It turns out they do so by oscillating their bodies in a specific way. These oscillations take advantage of the incoming flow and let the fish swim more efficiently. Physics-wise, water flow isn't that different from wind flow. So I decided to oscillate my blades like salmon, ran some computer simulations, and found out that we can actually increase the spinning forces, making wind turbines 4% more efficient than current turbines. I know 4% doesn't sound like much, but remember, 4% is about 1/3 of the way towards the maximum efficiency that we can physically obtain. Money-wise, this would mean more than $1 billion worth of extra energy for the US every year. We're currently working on advanced oscillating control strategies to go beyond that 4%, and we're planning also on implementing this on real-life wind turbines so that we can prove the concept. So please stay tuned. Thank you.